Welcome to another edition of Math Dive in 5 on comparing and ordering fractions. My name is Daryl Frost.
And I'm Barbara Knox. Glad you could join us.
So in just a moment, you're going to pause the video. You're going to complete the task on the next slide on your own or with a team or a partner. As you're working through the task, reflect on the two questions you see on the slide.
We'll see you back in a few minutes.
So Barbara, take a look at this progression with BEST. It's first through fifth grade here. Do you notice any commonalities?
Yeah, I see plot, order, and compare are the first four words in all of those.
Yes, and in first and second grade, we're talking about what?
Whole numbers.
Whole numbers. Then in third, we do the same skills, but we're talking about fraction numbers with either the same numerator or same denominator.
And I see that fourth grade is also comparing fractions, but this time they can be different numerators and different denominators.
More complex,
Correct.
more complex reasoning, and then same skills, but now we're talking about decimals to the thousandths place in grade 5.
Correct.
So take a look here at the actions. We just talked a lot about what on the previous slide when you think about verbs.
Plot, order, and compare.
There they are, and that within this trajectory, that they're doing that a lot with whole numbers, with fractions, mixed numbers, decimals, and then looking at fractional numbers as a vocabulary word. I don't know that we use that a lot, but that's something we need to think about. And then, of course, in the previous unit, they already know about numerator and denominator because it was understanding.
About that before.
Yes. The big idea here with the implications for instruction, there are 3, but what I want to focus on is that first one. Students need to have the conceptual understanding that when they're comparing, let's say, pizzas and 1/2 to 1/5, that we have to be talking about the same size pizza or
Correct,
same
because
size
if I have a little pizza and you have a big pizza, our fractional parts are going to be different sizes.
Now that's a good discussion point.
Correct.
Because students that would help them to understand fractions.
Right.
But when they're comparing, that has to be
Your
the same
half
size.
would be bigger than my half in that case.
Yes.
But if we had the same size pizza, our halves would be exactly the same size.
Exactly.
Mm-hmm.
So now we're revisiting that task where Mark and Henry each ordered the same size pizza and they each ate a certain amount of them. So thinking about 2 different number lines to compare the fractions and then using a comparison symbol. Tell us about what you see here, Barbara. I'm going to click that. Tell us about these number lines here.
Well, I see that you've labeled the number lines, so I know which pizza is Mark's and which pizza is Henry's. I see that they're divided into parts. Mark's pizza has 8 pieces and Henry's pizza has 6 pieces.
And the tick marks are labeled.
Yes.
And I even labeled anywhere from no pizza, which we could translate to 0, to the whole, which is the 1.
Correct.
And then what do you see underneath?
I see that you've compared those fractions in 2 different ways, depending on which fraction you start with. If I start with Mark's pizza, then I would use what you see in the white box, 3/8 is less than 3/6. But if I start with Henry's pizza, 3/6 is greater than 3/8. And I think it's important, Daryl, that they see both of those.
Yes, because it's not just, many times I think we have a tendency to lean towards what's greater.
Right.
But what's lesser.
Correct.
It's still a fair comparison and an accurate one.
Yeah.
So I think it's important that students can see both. The questions over here, what would be the biggest misconception?
Well, the biggest misconception with fractions when we're comparing is because 8 is greater than 6, when I talk about whole numbers, some students think that 8ths are greater than 6ths because they don't understand the purpose of that denominator. That denominator is telling me how many pieces make up the whole. And when I have a whole cut into more parts, those parts have to be smaller, right?
Yes. And that really kind of goes back to the unit previous to this, but you still are
Right.
going to have. So how would you address that?
I'd get out the tools. They need to see concrete tools or the pictures. Take a circle and cut it into 8 parts, cut it into 6 parts, and compare the size of those pieces.
And maybe even going back to that linear model with the fraction bars and comparing
Yep.
from a whole 3/8 to 3/6. What do you notice about the size of the pieces?
Correct.
All right. So task 2, in just a moment, you're going to pause the video. Once again, complete the task on the next slide or on your own or with a team or your grade level. As you're working through the task, reflect on the 2 questions you see on the slide.
Happy problem solving.
All right, so here we have this distance problem here where we have one student who ran a different amount on Monday and a different amount on Tuesday, and we got to figure out how to compare them.
Right. Which day did he run further? Which day did he run less?
lesser? I could look at it so it's got multiple entry points, right?
Yes.
So if I'm creating 2 number lines here.
Daryl, I notice your number line doesn't start at 0.
Why do you suppose that is?
Because he ran more than a mile.
And I think that's probably the major misconception when you think about mixed numbers and number lines. It's like not every number line has to start at 0. This value, both of these values, and I think we need to use that word also when we're talking about fractions because they are numbers.
Right.
They are number
We know he ran more than 1 mile and less than 2 miles,
2 miles
each day.
But I think that would be the struggle. And so how would you address that?
Getting out those fraction bars, and we have 1 whole mile and
a second whole mile.
A second whole mile. So my number line could even go from 0 to 2.
It could go from 0 to 2. But then connecting that linear model to a number line.
Yes.
Where they could actually almost like take a piece of paper and put it on top of the fraction bars, and they could trace it and then say, oh, well, what does this look like? A number line, right? And then you see the 2 comparisons there, just like you saw on the previous task.
Exactly.
But we still need to see it's not just about what's greater, it could be what's lesser.
Yeah, and when you're doing word problems with students, I think it's important to keep in mind the context of the problems. This one is definitely a linear context because when we run, we're running in one direct from point A to point B, which is more linear. Our last problem, pizzas, kids might think, oh, a pizza is a circle, so they might go to that circle model.
And would that be okay to do that?
It would be okay.
Yeah,
It's a little bit harder to draw 6 on a circle,
but if they're seeing it like that, then they can make sense of it. So taking a look at these 3 potential misconceptions, we've talked really about the first and third.
We have.
But that second one, the number line, is the tool that really helps that idea with comparison. If my number is to the right of what I'm comparing, it's greater. If my number is to the left, it's less.
And they should know that from using number lines way back as early as kindergarten.
With whole numbers.
Correct.
Yeah, the structure is still the same.
Yes.
So here's the CRA process. Obviously, in the concrete, we've talked about tools such as fraction bars or fraction circles, representational strategies, number lines, and we've seen that in today's Math Dive in 5. And really, the abstract is the reasoning, where the students are reasoning and justifying why a fraction or mixed number is greater or lesser.
Knowing that if the denominator is a larger number than another denominator, that it's going to be a less fraction if the numerators are the same.
Yes.
I'm reasoning because I know the size of the pieces have to be smaller.
As the number gets larger.
Correct.